Thank you for tuning in to Ellensburg Amplifier Repair and Service. This is going to be a long video of the repair of a Hifonics Brutus BRX1600.1D. So I have about 10 shots over a span of a couple days on repairing this board, and as I was reviewing each shot, I realized that my picture quality realistically was garbage. So I dug into a little bit more information on the cameras that I'm using and OBS here, and realized that I was not shooting in 1080. So I'm hoping that you guys will bear with me on these recordings, because these recordings are step-by-step process of what I did to repair this power supply section of this board that you see here. I didn't realize that I was not recording in 1080, so I'm sorry for any previous videos of their quality, and I do hope that you watch the videos. I do my best to try to help educate on the repair of amplifiers. Again, thank you for watching, and please bear with me on the quality of my shots here. I promise to make them better as I move forward. Thank you for watching. Thank you for tuning in to Ellensburg Amplifier Repair and Service. Coming back to this Hifonics Brutus BRX1600.1D amplifier, you'll find up here in the corner where I started the beginning of the repair of this amplifier board of the power supply section. So what we're going to do is we're going to go ahead and remove all the clips here and take the board on out, and we will move forward with rebuilding this power supply. So again, I do have this little dandy tool here that I use to remove the clips from this style of board. You'll find these in the Hifonics. The JL Audio uses these same clips. Who else does? Some of the cheaper amplifiers too use these clips. So if you happen to get any amplifiers that you're getting for parts, it's always a good idea to keep these clips. Don't dispose of them. Treat them pretty decent. Like I mentioned in the previous video, if you remove them in a way that bends them, and then when you go to straighten these clips back out, sometimes they do break. And these clips are pretty hard to come by if you don't get them directly from a manufacturer overseas that'll stamp you out 10,000 at a time. So I retain as many of these clips as possible when I rebuild amplifiers, or if I purchase amplifiers for parts. So what I did is I removed all the clips, and on these Hifonics amplifiers you do have to take the end plates off. So now what you got to do is you got to go around and just pull the transistors off of the thermal tapes here, just to break the seal of the thermal paste against the thermal insulators here. Because if there's one thing you don't really want to do is you don't want to damage the thermal insulators. You can get replacement insulators or strips, but sometimes if you're using something like a Silpad 900, it is quite expensive. So I try not to add too much cost to the repair of an amplifier. Most repairs that I do on amplifiers are about $35 to $40 for the power supply section, and depending on what card is used on the output section to rebuild the card, is about another $30 to $40 on the output section. So your average cost for an amplifier repair is about $70, which in my opinion isn't too bad compared to the original cost of the amplifier. So as you can see, I have moved back all the transistors from the thermal insulators. So that'll allow me to remove the board. Board can now slide on out of the heatsink, leaving you with just the heatsink, the LED control board there. So we're just going to gently put those in place there and set this aside, and let's inspect this board. All right, so here's the board. Let me get it all in view here for you. All right, so we got the board out of the heatsink. Our stray capacitors out and free. So let's see what we got going on the bottom side here. What we're going to do is we are going to be really focusing on the drive section of the power supply. Let me get the other camera into view here for you. So again, this is the area that I'm going to be focusing on, is the burnt pre-driver section here. So let me sketch this out real quick so I have note of where all this is going and how this is going back. It's very important that you get these in the right direction. If you get them in the wrong direction, you will burn up your pre-drivers or the drive card itself. There's a lot of damage that can happen there. So I will be right back with you once I get this all drawn up here. And what I'm going to do is I'm going to go over to my other bench here real quick with my Hacko, my 808, and I'm going to pull all these solder off the transistors, the gate resistors, and free up the pre-drivers here. And I will also desolder the 4 capacitor locations, and I will be right back with you guys. Alright, so I am back from desoldering the transistors, the gate resistors. I did some desoldering on the pre-drivers here for the power supply. That solder, I should say this lead-free solder that got super hot, just destroys the properties of solder. So it's really hard to get that back out. I really got to mix it in with some leaded solder, or I'm going to wait and see if I got to remove those vias due to the carbonized board here. I also desoldered the legs of the capacitors, and that's pretty much where I'm at for the desoldering. I did draw out my little map here of the placement of the pre-drivers here. That's always, like I mentioned in the previous video, it's always a good idea to either take a high resolution picture of what you're going to be working on, or draw it out so you know how it goes back together. I do have the layout of the power supply pre-drivers here. So you got your A1275s and your C3228s. So I have the parts used, I should say, in the power supply, and I have the layout of the pre-drivers for the power supply. So what does that leave us with? Well, kind of a mess. So let me flip this over here and get rid of some of the burnt stuff here. So what we're going to have here is just a pile of parts. that are going to be disposed of. Gate resistors, power supply transistors are all going to be replaced. I'm one of those technicians that do not reuse parts after it's been severely damaged prior. So as to avoid any future problems of transistors burning out due to a previous high stress situation. So from here you need to make sure that your board is intact, that there's no damage to any traces, no burnt areas of the board that would be potentially carbonized. And from there you can proceed with cleaning up the board. So what I do is I use our trusty Q-tips and we just go to town on preparing the board for new resistors and new transistors. So far I'm quite pleased that the gate resistors did not burn the board too bad. Just a little bit of resistor residue left on the board. You'll see here in just a second that those gate resistor locations are fairly clean here. Yeah, it's cleaning up nicely. The areas that I thought were going to be burnt are not burnt. It looks like all the silk screening survived. And the transistor locations, even the silk screen survived. I'm using a solvent here that is quite harsh. It's not isopropyl alcohol. It is a, let me see, what is this stuff? This is some denatured alcohol. It is quite harsh on boards. It's a lot easier to clean up after some burnt components using this denatured alcohol. You got to kind of be careful with it though, selective I should say. This stuff will take the markings right off of certain diodes. It'll wipe the numbers right off of it, and it'll take some coloring off of some of the cheaper resistors. So I use this mainly as a quick clean for these highly burnt areas. I just wipe down the resistors real quick to help identify the values of those resistors without taking off the color bands. But as you can see, this stuff it goes to town on the residue of burnt components a lot quicker than isopropyl alcohol. You got to do a little bit more cleanup afterwards with denatured alcohol, and it is obviously highly flammable compared to rubbing alcohol. So I use this very cautiously. Always make sure that the capacitors are discharged. You don't have any static build up anywhere on your board to spark a fire. This stuff evaporates really fast, so it doesn't stick around long when you're cleaning the board. And just like that, I'm not going to do too much cleaning around the pre-drivers because I also need to note any topside traces that need to be repaired. So what I'll do is make note of the topside traces and go from there on rebuilding that. Let's see if we can pop these capacitors out of here. So I did desolder the legs. So I just peel it back. After desoldering the legs off here, you're going to hear some popping and cracking. Completely normal when removing these because they are glued to the board. Just like that. Get my discharge resistors back up off the board. So this is pretty much the steps that I take in repairing an amplifier. There's no special processes. Just some general cleanup, removal of parts. I do recommend having a good solution to removing components, such as a desoldering tool. It does help keep from damaging into the vias or traces by using an iron extensively in one spot. So I'm going to do a quick draw out of the top side of the board here for the pre-drivers and be right back with you again. Alright, I'm back with you guys. Here on this board, I did dig out the burnt PCB here around the power supply pre-drivers. As you can see, I do have quite a substantial hole here, and I have another hole here. So as you can see, we're going to be replacing the transistors, the resistors, and I will also be replacing this capacitor here. So this whole section here is going to get rebuilt with a new epoxy base and get all the traces put back together. So what I'll do is I will prep the board up here for the epoxy, and I do have a video that I had posted in the past that you'll find up in the corner here. A video that demonstrates how I do these repairs. So I will I'll get my Captain tape set up. We'll get some temporary transistors poked into place. We'll get some epoxy mixed up. Get this poured. So stick with me. We'll get this together. We'll be right back with you. Alright, so I've cleared out all the resistors and the capacitor from this location here, and I cleaned up all the flux residue off the board. So now what I'm going to do is I'm going to take my Captain tape and I'm going to just put a layer of Captain tape on the bottom of this board here. And then I'll show you again how I go about repairing holes in these amplifiers. So I just take my Captain tape and lay it directly and completely over the spot that I'm going to be so what I'll do is just take my eraser and push the Captain tape down completely against the board, getting rid of any of the air bubbles around the hole where I'm going to be applying the epoxy to. That way the epoxy doesn't run underneath the tape into the areas of the board that I don't want epoxy to go into, like the surrounding vias here. I don't want to fill those full of epoxy. I mean, epoxy is not too bad to pull back out of areas just before it cures. It's really a rubbery substance as it's curing up, which is really easy to remove from any part of the PCB or vias or traces, as long as you get it before it's completely cured. And that's pretty much what I do here for this. We'll flip it over here and you'll see the top side of this. Let me move the cameras here a little bit. And let me change views here. So as you can see, what you'll have is just a section here that's got the tape. You can see the tape, and that it's sealed all the way around the edges of the hole. So I'm going to do is grab some transistors. I'm just going to temporarily poke them through the tape, which will make a good seal around the leg of the transistor. And then we can prepare to fill up that hole there. So let me grab some transistors. I'll be right back. All right, so let me find the transistors here that we are going to need on this board. So we need some 3 228s and some 8 1275s, which I happen to have here. So I've got the 3 228s, which is 160 volt 1 amp NPN transistor. I'm going to need 2 of those, and then 2 of the 1275s. So let me grab 2 of these here that have nice straight legs that I can poke through the tape, and then 2 1275s here. So I got the 3 228s and the 1275s, NPN and a PNP transistor. Make sure the legs are straight for the. And then I have a 1275. You just straighten up the legs. And this 1275 here. All right, so I've got my little roadmap that I made previously that has the layout of the transistors for the power supply pre-drivers here. So it starts off with a 3228. So I'm going to take the 3228 here. I'm going to reach right underneath this board with my finger, and I'm just going to poke that 3228 right in the location, just like that. And then I leave the transistor somewhat high so that I can work the epoxy around it. So then we have a 1275. And I'm going to poke this 1275 right into place. And then the next 1275 over here. And then the 3228. And just like that, as you hear the transistors snapping through the tape there, I'm just going to raise these back up. As you can see, they're just poked through the captain tape there. They're up quite a bit so that I can work around the legs of those transistors. And what we're going to do is just mix up the epoxy, match the color, and we will get that epoxy laid down and fill up the voids here. I'll be right back with you. All right, so let's go ahead and mix up some epoxy here. It's not going to take very much, so we're just going to do a little bit of A here. And a little bit of B. Try to get the ratios just a little closer there. Perfect. And then what I'm going to do is I'm going to take my colors here for my, I call it the Hifonics color. We're just going to take some color here. We're going to go ahead and put a drop of this blue in. And we're going to put a drop of this blue in, so that adds just a touch of green to it. And then we got the blue. And we're going to go ahead and mix this up. Yeah, I know this is the boring part, watching things get mixed up and put together. But I'd figure I'd show you how I do this. Just mix it up the best I can here. Make sure your part A and part B is thoroughly mixed, otherwise you're going to get a bad cure on it. You'll end up digging it back out of your board. Just like that. And then what I do is I just I grab my toothpick here and just start scooping up this epoxy, laying it right into place. So if you put your epoxy in right after you mix it up, it is pretty thin, so it just kind of flows into place. And I just use the toothpick to kind of guide it around the legs. And I try not to get it in any of the vias that I don't want to fill. So there's one. And now I will fill the second one here. The second one is not as big as the first one, so it's not going to take as much epoxy. Then I just bounce the tip of the toothpick around in the epoxy. It kind of helps settle it into the corners and little nooks and crannies. Making sure that the transistors are placed where you're wanting them to be, because once it sets up, that's where the holes are going to be present in the epoxy. And that's looking pretty decent there. Just like that. So that is the small board repair. The epoxy will set up now, and I use the legs of those transistors to make the mold for the holes. So in this case here, I'm not going to do via replacements. I'm going to use trace jumpers on these, because these are areas here where the main traces are still intact. So you have your positive trace here, and you have your negative trace going to your transistors, which are still intact. Your current carrying traces are still intact. So It's just the signal trace that I got to rebuild, which is low current. And we'll move on from there. Once this is cured up, I'll pull those out. We'll shape up the epoxy, make sure it's all nice and flat and good to go, and then we'll rebuild it. I'll be right back with you again. The epoxy here is set up quite well. I am pleased with how it's going, so I am not concerned or worried about having to rip it back out of there. Otherwise, everything's looking good. And I'm going to prepare to get another capacitor for this capacitor location here, C219, for this capacitor. And for that, what I'm going to do is take, what was that? That was that capacitor was a 105J, 100 volt capacitor. So I have a kicker board here that is just a gold mine for parts. If you ever are in need of surface mount components, find yourself a kicker board that is not economical to repair, and you have all sorts of parts that you can choose from this board. They use a lot of different variety of capacitors on these boards, so they're good boards to have laying around in your parts bins for pretty much a lot of different parts. So this is where I'm going to be taking this capacitor from. Again, it's a 105J 100 volt capacitor. So I will heat up the desoldering gun here and get that pulled. And just like that, I get the capacitor pulled off that board. And now what I'm going to do is I'm just going to use my MK328 here just to verify the capacitance of this capacitor. This is a pretty good little tester here to tell me capacitance. So I really enjoy using this. And as you can see, there's the result that it's showing. To me, I like using it. They're good little machines. I mean, I wouldn't use this as a lab grade piece of equipment, but this does confirm, especially with capacitors, it's really good on capacitors, the capacitance and the ESR of the capacitor. So as you saw on the screen, this capacitor is absolutely good to go. So I will place that just temporarily in its spot where it goes. And resistors, and on my little map here that I drew out before I removed all that burnt board, is I laid my little road map out here. So I need two 470 ohm resistors and two 3.3K resistors. So let me grab those real quick. Two 470s. If you check out my submission on Keysight, you will get a tour of my work area. My work area is updated since that video that shows the layout of my workbench, both workbenches, and the and my load center, which I just recently finished up. My 8K oil immersion load, and my lithium iron phosphate battery bank, and my Taramps 240 amp power supplies. It's a switch mode power supply that I use in conjunction with my BMS for the battery bank. So I'm good to test up to several kilowatts, which I've been wanting to do for a long time. It takes so much time to put a load bank together and find the best design for the load bank. The epoxy is setting up nicely. So I'm probably going to assume that it's going to be about an hour or so for me to be able to pull these transistors out without the epoxy deforming on me. So I'll have to take a slight break here from the camera, let the epoxy set up, and just to let you know, by popular vote, the kicker capacitors are going in. So we are going to be making our hybrid amplifier here using kicker capacitors in a Hifonics board, or if you want to call it a Maxonics board. Maxonics is the manufacturer of Hifonics, so I know these boards very, very well. I've been, at the beginning when I was starting to repair amplifiers, I was in direct communication with the engineers. The engineer, it was a single guy, for Maxonics to be one of their repair centers. But that didn't go through, so even though I know their boards inside and out, it's fine with me. I'm independent. I'm not contracted by anyone, and I make my own decisions on what I replace on the boards instead of being directed to replace just one of a bank of transistors. So I will be back with you. I'm going to let this epoxy cure up a little bit more, and we will push forward on this. Thank you for watching, guys. I'll be back with you again. Welcome back. We are ready to go ahead and remove the power supply pre-drivers here. Epoxy's all set up, good to go. So what I do is I take my angled tweezers here. I just reach right underneath the transistor and pull the transistor straight up out of the epoxy. And what that does is that allows, it leaves the 3 holes behind through the epoxy. And I just do that with each transistor. Pull that transistor back on out of there. And you'll hear it just does a slight little pop as it breaks the seal against the leg of the transistor there. And now we're just left with the nice flat section here of the epoxy and what's left of our traces. Which doesn't look too bad. I think this is going to go back together fairly decent. Not seeing any major problems that could arise. So what I'm going to do is I'm going to clean up this epoxy area here and prepare to start rebuilding some of these traces. And I just wanted to point out, I notice everyone has voted on these kicker capacitors, but these kicker capacitors are actually made by the same manufacturer. So that's a quite interesting observation there. They're by the same manufacturer. They're both SK capacitors. It's just one is a little bit different diameter than the other. So that's just something I wanted to point out to you there. So I'm going to clean this board up here, and I'm going to prep the trace area for the rebuild of the transistors, and we will put that back together and see if it's functional. I'll be right back with you. And I got the top side of this board cleaned up here. So I got the epoxy all cut down, flattened out, which really does help me see the trace locations clearly. And now what I'm going to do is I'm going to just peel this tape off. This Captain tape will kind of get stuck to epoxy, but if you just carefully peel the tape up, it will separate from the epoxy. If you go too fast, you're just going to peel the tape and leave the tape behind on the epoxy. But if you just be gentle with it and peel the tape up, that's what you have left. So what you have is just a nice flat section of the board left with the holes that I can see the transistors had left for me. I can see the trace locations that I need to repair and put back together. So I just thought I'd show you what it looks like after the epoxy work has been done and the tape has been removed. We will move forward to repairing the traces now. Stay tuned. We will get this up and running once again. Right. So as you can see, I have finished the repair of the traces to the power supply pre-drivers here. I did use a solid copper wire for most of the trace repairs there. And what I'll do is I'll show you what I use for my traces. What I do is I use transformers that have auxiliary windings, and for instance this transformer has 3 different size wires in the transformer. We've got the secondary winding, the primary winding, and the auxiliary winding. So these work out really good. They are enamel coated, and they work really good for jumper repair. So what we'll do is we'll go ahead and fire up this amplifier here and see if the drive signal comes alive. Let me hook up the ground here on my scope, since this is a floating power supply that I use here. My 2 amp isolated power supply. So I'll turn that on, and so far we're looking good. Let me get channel 1 here somewhere. Probe. Let me do this a little differently here. As I get all this organized here for you guys. There. That's better. Alright, so let me fire up channel 1. And let's get the scope on the screen here for you guys. Let me get the software started here. Alright, let's just verify that I have, yep, I do have the signal. Do I have the scope up for you guys? Yep, I sure do. So we're going to drop down to 5 volts on the division. This is a drive signal that we're looking at here, so 5 volts per division should work out pretty good. I'm just going to pulse the power supply just to make sure that nothing shorts out. I do have a green light, and the relay engages. So far we're looking promising. there's our drive signal. 5.86 volts, 5.8 volts. Yep. So we do have a nice, good square wave on all the gate resistors here. So the drive did survive, and no heat. I have no heat building up on the transistors. Looks like it's getting pulled back to ground decently. Looks like all the diodes are functioning. So it looks like the drive survived. Nice, so we're good to go ahead and install the gate resistors, and probably go ahead and put in the output or the power supply transistors, and we will install our 4 kicker capacitors there for you. That should take care of the power supply section. There is 2 shorted output transistors, so what I'll do is I'll get the power supply put back together, the capacitors put back in, and we will come back to moving on to the output section. So that is the beginnings of repairing an amplifier. So I'll get the gate resistors in, power supply transistors in, and we will move forward from there. Alright, we're back. As you can see, I have the power supply transistors installed. I used 3205s with 47 ohm gate resistors. I may have to go up to a 68 ohm gate resistor, just depends on how these are being driven, how the signal is being driven back down to ground. So I just have to watch that and the temperature of the drive pre-drivers there. So as you can see, I've got the kicker capacitors installed, and sometimes people ask, well, what direction do these go in? So your negative side of your capacitors will always go to the negative of your rectifiers. These are using, I think these are using doublers, and the board is labeled here, positive and negative on the board, so I verified that I do have the negatives going to the negative and the positives going to the positive. So before we can power this up, we do have to take care of the shorted output transistors. Then the easiest way that I check for shorted outputs, well, first we go to diode mode, and you'll hear the constant beep that there's a short there. So what I do is I switch to resistance, and I just check across the gate and drain the resistance. And for instance, this transistor is reading 21 ohms exactly. This one's reading 1.2 ohms. This one's reading 21 ohms, and 21 ohms, and 21 ohms. So you know right off the bat the transistor that's reading 1.2 ohms is going to be your shorted transistor. So what I'll do is I'll just bend that down for now. That tells me that that one is shorted. And then, excuse my reach across the camera here. So then I'll check this one. There's 20. There's 20. There's 20. There's 20. And there's 0.3. So you know that one's shorted. So from here, what you can do is you can remove the shorted transistors. So what I'm going to do is I'm just going to cut the legs off here, leaving some of these legs exposed for me for when I go to desolder the legs. They're just easier for me to grab when I pull them out of the board. Excuse the reach again. So that takes care of the shorted outputs, and then we're just going to verify, double check that the resistance is where it should be, about 20K, and we're 19.78. So we look good, 19.8, and we're gonna check the other side, 19.8. So we're about that 20K is what you're looking for on these for the output transistors. I think those are 640s. The IRF 640. Let me double check and see what they're using on the output here. They are using, yes, the 640s. Another common transistor that Maxonics uses in their Hifonics boards. And again, this card has been covered before. So what I'm going to do is I'm just going to go ahead and pulse the power supply. We're going to charge up the rail capacitors here. And at the same time, hopefully, if I don't have a drive problem, as long as these are getting pulled to ground, these do have ground resistors that pull the signal back to ground, that it should fire up for us. So I'm going to fire up my thermal camera real quick. So I'm going to fire up my thermal camera here just so we can keep an eye on temperatures. With my Flare TG167 here. And I just want to double check, make sure that I'm good. Go ahead and turn the power supply on. Check my power supply transistors. And I'm just going to pulse the power supply real quick here. And let me get a scope on this real quick, so I can keep an eye on the gates of the power supply. So I'm just going to attach my probe to one of the gates here. And then I'm going to take channel 2. I'm going to move channel 2 to 50 volts. And I'm going to watch my positive rail voltage. At the same time watching for any abnormal heat. So here I noticed that my microphone input is not working. So here I'm going to be demonstrating the power supply, the results of the rebuild. The power supply was heating up, so I did have to pull the output card, and I removed all the 640s on the output section. So what I'm doing is I'm just double checking things here, and the transistors are running cool. They're not warm at all to the touch, and you'll see a positive rail voltage building here on the scope, and then the drive on the power supply transistors. So this is just a demonstration of the power supply up and running, showing you the positive rail voltage alongside the drive at the gates of the transistors. And if you notice, they are getting pulled pretty good straight down to ground and just a little bit below ground there. That's the way they should be. So this is a good result on the power supply of this amplifier board. And from here we're going to go ahead and move to the output section of this board. We'll probably rebuild the output card and put new 640s in and get this thing fired up for you. So again, this is just showing you the operation of the power supply, and sorry for the input failure of the microphone there. So this is just my narration for you. to kind of go over what you're seeing here. Again, I do thank you for watching.